Okay, let us start our mission. First question, you're asked to solve this equation. Alright, it is not a search question, it is an indices question. Okay, now you take a look at the base and the index. Index are all in terms of x and numbers. The base is 64,832, so the correct base to change to would be 2. Okay, 2 to the power of 6x, that'll be 64x. Square root, you change it to power half. You take 6x times half, you get 3x. On the right hand side, you change this to base 2, so that'll be 3x plus 3. Change this to base 2, that'll be power 5 times this and times this. That's how you got this. Okay, the next thing you need to do is, I would recommend that you bring this up. Alright, many of you are very fond of cross multiplying and then multiplying this by this. Try not to, because it's very straightforward from here that when you bring this up, you get 3 minus 5, that's minus 2. When you bring this up, it is plus 10 and you get 13x. Okay, if you were to cross multiply, tendency is that some of you will get confused whether it's to add the power or to multiply by these powers. So strongly recommended that you work everything on this side, alright, unless the base is different, then it's a different matter, but it depends on question as well. Okay, now that both the bases are the same, compare the base and you get the answer. So that's question 1, pretty straightforward. Now let's look at question number 2. It's something which we have just learned not too long ago. Okay, you're asked to express this as partial fractions. Now let's take a good look at this whole expression. Okay, you have minus 4x cubed and this whole thing divided by x, 2x minus 1 and x squared plus 3. Now, first of all, you need to decide which case it is. Meaning, you have to look at the denominator and ask yourself, is it linear factor? Okay, is it linear factors? Or is it repeated linear factors? Take note, repeated linear factor is not the same as irreducible quadratic expression. Okay, so take a look at this. For the first one, obviously x power 1, so it's linear factor. Okay, so the numerator that I need to put is 1 less than the power here. That means x to the power 0. X to the power 0 is 1, so I don't write. So it's just a number. A is just a number. Okay, so that settles this denominator. The second one, linear as well. So I just write a b. Okay, 1 power less than the denominator. Now the third one, notice that you cannot factorize this. Okay, so that's what we meant by irreducible quadratic factor. Okay, so you put here as 1 less, 1 power less, and then plus another constant. Okay, so this is how you can express this in terms of its partial fractions. Now take note, A, B, C and D, although I write A, B, C and D here, one of these could be a 0, they may not have actual numbers. One of these might be 0, okay, but everything will be clear to you as you work it out, so don't be surprised if you get 0 for let's say C or D. Alright, we will see later. Now some of you may think, oh, is this improper? Because there's one more case, right? Improper. When will it be improper? The case of improper fractions. Okay, it will be improper if the numerator, the power of the numerator is larger than Okay, there are some other expressions here. Larger than the power of the denominator. So you see 5 here, that's larger than the denominator's power, correct? So this is considered improper. Now, even if the power of the numerator is the same as the power of the denominator, it's also considered improper. Okay, so there are two cases in terms of improper, but in this case, it is not improper, all right? So there's no need to do long division and all that. Okay, let's move on. After you have done this, the next thing you do is to put a big bracket here, multiply by all the denominators that you see here, because we are trying to remove all the denominators. Okay, you multiply by all these three factors, you end up with this. Multiply by this 1, 2, 3, x will cancel with this x, so you're left with these 2. Okay, multiply by these 3, the 2x minus 1 will disappear, so you end up with these 2, x and x squared plus 3. Finally, you multiply by this 3, right? Your x squared plus 3 will disappear, and you will be left with x, 2x plus 1, of course with the cx plus d. So this is what you get when you multiply both sides of the equation by x bracket 2x minus 1 bracket x squared plus 3. Okay, so this is what you get. Right, now what do we do after this? Let us work smart. We don't want to expand so many times. Okay, so we sub in certain values that will make some of these complicated looking things disappear. Okay, and the obvious choice would be substituting half here. Okay, you set 2x minus 1 to 0, you will find that x is half. When you put half inside, this will disappear. Okay, this will not disappear, this will disappear. So 2 of these will disappear, and you end up with only b. Okay, put half inside the right hand side as well, don't forget to do that. And then you just press your calculator, you'll find that b is a very nice number 2. Okay, now how do I find a and c? Let's take a look. There is a factor x here, so if I were to put x as 0, this will disappear, this will disappear as well. We're only left with the term containing a. Okay, so you put 0, 0, 0 on the left hand side, you will just have 9. On the right hand side, you put 0 here, put 0 here, you get minus 3, and that's your a. Okay, now we have so far found a and b, but there's still c and d, which we are required to find. So we have run out of numbers to substitute in that will help us to cancel off terms easily. Okay, now what we can do is, as discussed in class, you can substitute any number you want inside. Okay, you can substitute, let's say 1, and then you put it inside here, put it inside here, you get one simultaneous equation. Then you substitute maybe 2, then you put inside, and then you get another equation. Alright, but I'm not going to do that here. I'm going to show you another method. I'm going to compare coefficients of x cubed. Why? Because I noticed that if I were to compare the coefficient of x cubed, on the left hand side it's just minus 4. On the right hand side it's just this times this times this, right? A times 2x times x squared. But we really know a, so later we can just put it inside. I'm just writing the unknown first. How about b? What are the x cubed terms here? It's just bx times x squared to get bx cubed, correct? So I just take the coefficient, put here. Okay, how about c? Cx times x is cx squared. Okay, but this whole thing will be multiplied by this again later. So you have 2c as your coefficient of x cubed. So that's how I got this. Put in a, put in b, I'll be able to get c to be 0. You see, c can be 0. That means in the first place there is no x term here. Alright, but why did we put that in the beginning? Because we don't know that there isn't an x term there. Alright, the constant itself is enough to power this up to this expression. Okay, as discussed in class yesterday. I think some of you were asking yesterday, so I hope you understand this now. Okay, I am also going to compare the coefficient again. In this case, I'm comparing x. Okay, do the same thing. X on the left hand side is minus 16, so I put minus 16 here. On the right hand side, I have to see carefully. A times minus 2, A times 2x, I get 2a. 2a times this number here will give me 6a. Okay, now how about b? B, I have here bx times this 3, I will get 3b. Okay, now let's look at this. C can't give me x term, because you see cx times x, I get cx squared already, but later I still have to multiply by this, which is cube, which is not what I want. If I multiply by this constant here, I'm already power 2, I'm already powered up to 2, so that is actually beyond x already, it's more than x, so c is out of the picture. That's why you only have dx times minus 1 here. That's why you get minus d. Alright? So you have to be very careful when you compare coefficients like this, especially when there are 3 sets of terms involved. Alright? Multiplied together here. Okay, then you work it out, you get d equals to 4. Now we have found a, b, c, d. Don't be too happy, this is not the end. You have to write the final answer as this. Alright? See carefully, your a is minus 3, so you put minus 3 here, then you will get this, right? B is 2, then you get 2 over 2x minus 1. C is 0, so don't need to write. D is 4, so put a 4 here, and that's how you got the answer. Yeah, that's all for question 2. Now question number 3, I think is area of weakness for quite a few of us. Most of us are not very strong in manipulating sets, so I'll be giving you more over the next few days. But this question relatively is a very straightforward one, okay? Nothing much. I thought it's a good question to start with our revision. When you have this fraction, whole thing square, what it means is that you are going to square the numerator as well as the denominator. Okay, so I'm going to square them separately. Now, squaring this is something like a plus b squared, a minus b squared. Alright, so I'll get square this, 2 times of this times this. So you get this, square root 5 times square root 3. Square root 5 times square root 3 is just 5 times 3 square root here. Okay, do the same for the denominator, you end up with this. Now you combine the 5 and 3 together, you will end up with this. Alright, now how do we continue from here? Now in mathematics, right, you cannot leave your answer in this form whereby the denominator contains surds like this. Okay, we normally want the denominator to be free of square root, and that means the surds here, so that it is just a nice integer. Why is that so? Because in real life application, most of the time we will use this expression, it may represent something in life, and we will combine this with some other expression to add, multiply, or to subtract something, and we normally want the denominator to be a very nice integer so that we can easily combine the surds together. Alright, so we have this thing called rationalizing the denominator. Rationalizing the denominator means, you see, right now the denominator is irrational, right? Irrational. This is irrational, square root 15. Of course, this 2 and 8 is, minus 2 and 8 is their rational, but this square root 15 is not. So we need to rationalize this whole expression, this whole number here. So what I need to do is to use a minus b, a plus b, which you learn in Sec 2. Alright, so if this is a minus, this has to be a plus. Okay, now let me ask you, if this is a plus, this should be a minus, is it? Should it be a minus? No. Okay, this is a very common mistake, and I want to highlight here. During exams, you may be in a rush, and then you see, oh, okay, you just change the sign, and then when you see this, you may just change the sign. It's quite common to make this mistake in an exam. Please avoid this mistake. It has to be both plus. That means you are only rationalizing the denominator. And anyway, whatever you multiply to this fraction, it must be equivalent to 1. Okay, this divided by this is just 1, right? So effectively you are doing nothing to this number, which is the original number here. Okay, you cannot be multiplying this thing and then you change the whole number altogether already. So take note of this. Consciously tell yourself not to make this mistake. Alright, already some of you are making this mistake in your previous work. Okay, now what to do after this? This would just be a minus b, a plus b. So you square this, and then you do the rainbow method. Okay, and then you end up this. Now be very careful. In search, right, you must always leave your answer to the simplest form. And this is obviously not the simplest form because there is a 4 factor here, 4 factor of 4 here. So you take out common factor and you find that the final expression is so. Alright, that's all for this question. Let's go to number 4. Oh, sorry. We have a 3 part 2. Yeah, question 3 part 2 is, okay, they tell you that, let me see the question. Okay, never mind, you refer to your own question. Basically what they're trying to tell you is that, okay, y is this, and then this y, right? This y, if I didn't remember wrongly, they're trying to tell you that this is less than 0 only if this is true. Okay, square root 3 minus 1 here. So s is between square root 3 minus 1 and k. We don't know what is k. Okay, but from what they give us, alright, we are able to know that this coefficient of x squared is positive. That means your curve is a happy face. Okay, curve is a happy face, and these two values tell us that, of course this is smaller, this is bigger, right? So it tells us that, oh, the curve cuts the x-axis at this value and this value, this point and this point. Okay, so you just indicate this, it will help you. And how do I know that this is the shaded part? Because they want this curve, which is a happy face, to be less than 0. Equals to 0 is exactly this line here, but they want less than 0, so they want this lower portion here. Okay, as indicated by this inequality. So from here, you know that your x has to be square root 3 minus 1 or s equals to k. And then you work backwards. You make the right hand side equal 0, make the right hand side equal 0. You end up with this. Okay, and the inequality that give you in the beginning is less than 0. You follow. What to do after this? Work backwards. You expand and all that. But then take note, x times x will only give you x squared, right? But what they want is 2x squared. That means this quadratic expression here, this part here must match this part here. So there has to be a 2 here. You cannot leave out the 2 here. Always remember that your expression must be in the form ax squared plus bx plus c. Alright? Now, you do some algebraic manipulation, you will find that you end up with this. Notice that I like to do grouping in this way. Normally I put a plus here, but you see I actually correction taped it. Why? Because I realized that they put the minus outside. Okay, which means that this p is exactly what I have inside. So I follow the format. If this is a plus, I follow the format so that I can straight away compare the coefficient of x. Okay, so x, right? This minus and this minus. I can ignore this minus and this minus already. This x and this x I ignore. I compare only the coefficient. So p equals to this, and if I were to combine them together, I will get k equals to this, okay, which is this. But again, as I mentioned, whenever you see surds, okay, in the denominator, meaning the denominator is not rational, right? It's not a rational number, right? It's some non-ending weird number. You have to rationalize it, okay? So you have to rationalize it, and then you get this. Okay, now you see the denominator is a very nice one, and you can see here that I actually reduce it to the simplest form. So this is your k. You have found k already. Now you still need to find p. So what I do is I sub. Oh, sorry, this should be 2. This should be 2. 2 you sub into 1, you will get this, and then you will end up with the final answer p. That's all for part question 3. Yeah. Okay. Now, for the next question, they asked you to sketch something like this. Y equals to 2. Okay, this one. Now let me ask you, is this exponential function which we learned? Exponential function. Is this exponential function? Okay, let me just rewrite this. This will be 2 here, right? Root 2, so it's x3. Is this exponential function? No. Okay, because exponential function means the power. Exponent means power or index. Okay, it means that the x or the unknown is at the power, is at the index. Alright, but you notice that the unknown is at the base, so this is not exponential function. This is not. Alright, now what and how do we draw this? Actually, I've not really taught you this, but it's good to expose yourself, okay? It's actually just common sense. Just think about it. Use your common sense. There's nothing difficult about this. Think about it. X is here. Now, if you try to draw a table of values, 0x, then you have, no, not 0x, sorry. X, y, okay? X, y. And then you put 0 here. When x equals 0, oh, this will be 0, right? Now, how about when x equals negative? Can you square root negative 1? Cannot. So, it means that there isn't a negative portion to this type of graph. There is only, there's only a positive section to it, okay? Positive here. No negative. That means x cannot be negative. Cannot be there. There isn't this part here. Alright? So now we focus on the positive part. Now, is this what we call linear graph? No, linear graph is power 1. But this power 3 over 2 is actually more than 1. Okay? So let's try. You can go back and try all these 3, whatever. You will find that it doesn't go linearly like that. As you put in the values of x, right? The y value will increase and increase and increase faster. So it will not go like that. It will go like that, like that, like that, like that, like that, like that, like that. So it's actually a curve, which is what I have here. Okay, so what I have here, a curve. So this is 0, you have to label this 0. Then you label the graph itself, x, y here, then you get the marks. Okay, so it's all about common sense. Now, how about the second part? They ask you to find the point, I think, of intersection between these two. Alright? Basically, just sub 1 into 2, solve simultaneous equation, and that's all to this part of the question. Now, I want to ask you, how you intend to continue from here? Is there a need to so-called plus 2x on both sides so that 2x appears here instead of this side? Then you square, what can you do after this? Alright, just want to tell you that there is no need to do anything, no need to move things around. You straight away square both sides. Because when you bring the 2x over and then you try to square to get rid of this, you will find that you won't be able to get rid of this. Okay, you square this, but you will end up with 2 times of this and this, 2 times of this and this, and that will be 8, right? 8. But you see, you end up with this irritating square root thing here, and then the whole thing become very, very complicated. Okay, so what you need to do is you just work from here. Okay, but in the exam, this expression, why am I discussing with you this? This expression might be on the left in the first place. So what I'm trying to tell you is that if it's on the left in the first place, you should not be squaring both sides first. You should minus 2x on both sides and make sure that this is here before you square it. Okay, so this is one common mistake that some of you make in your pop quiz. I think 1 or 2 inserts. Okay, then after that you expand and everything. Oh dear, you see, now we have this which is not quadratic. Okay, it's cubic. So it's actually solving cubic equation question hiding inside here. Alright, so how do we solve this? I hope you remember how we solve this. Remember the factor and remainder theorem which we learned 2 days ago? Okay, so what do we do first? What we can do is you let fx be this first, alright? Because we are using remainder factor theorem, so we just call this function x. You can call it px, fx, gx or whatever, but normally we use fx, alright? Can you remember how to find the factor of this? Now a shortcut is, you use a calculator and then you press in 4 minus whatever, and then you get x equals 1 as the answer, right? Oh, which means that we just put in 1. Okay, you need to show this working and show that it's equals to 0. Okay, no need to press this. The calculator already told you this is a factor, right? Don't waste time pressing all this. You just sub in, show them you know this. They will give you the marks. Okay, then make this statement. Alright, now after you have known that x minus 1 is a factor, this will be equals to x minus 1 times something. Now what is that something? Let's go through now. Okay, I don't want to waste time writing this whole thing, so I just write fx here, but you are supposed to compare this with this. Okay, this with this. Okay, what times x will give me 4x cubed? It has to be 4x squared. Alright, we always attack the front and the back. Okay, the next one, what times minus 1 will give you minus 16? It has to be plus 16. Alright, so you have ax squared plus the bx plus c. So I use a constant k, and we need to find this constant k. Again, I compare coefficient, minus of x squared. Okay, so x squared will be minus 4 on the left, then on the right, this time this will be x squared, right? Okay, so I have a minus 4 here. This times this also will give me x squared, so kx. Yeah, remember not to write the x squared here and the x squared here, or worse still, you just write one of the x squared here, and then later when you do right, you find that you may think that I don't know what is x squared, then you'll be complicating the whole problem for yourself. Okay, so that is another common mistake that students make when they compare coefficients. They forget that they're only comparing coefficients, so they write the x squared and the x cubed here, then they thought that they had to find this, then they go and solve simultaneous, then it's a whole long story and you end up with 0 marks. Okay, so be very careful. Now you have found k to be 0, which means that the expression is this. Okay, if I take out the 4, it will be this. Oh, that means I can actually find the answer. Okay, now actually when you press your calculator to so-called check the answer right from the start, right, you would have seen that one of the answer is 1, the rest are like, 2i or something I. The I means imaginary. Okay, imaginary number, that means it's not real, so no solution. Alright, you will find that, yeah, there's no solution. So that's all for question 4. Yeah. Oh, they want you to find the point intersection. Okay, so point intersection between this curve and this line, right? So there's a line here, okay, cutting here, because this will be plus 4, negative gradient, and intersecting at 4, or the y-intercept. So this point, okay, how do you find this point? You already know that x is 1. Put the x1 here, you'll be able to find the y, which is 2, alright? So that's what I did here, that's the point, and that's all for this question. Now let's move on to the next question 5. Now question 5 is an interesting question. You probably will be stuck here and don't know what to do. Reason is that you need to use some common sense. Common sense can be taught, and I've not taught you that technique of common sense, so you may have problem, but never mind, let's do it. Okay, you are told that this point is this, C is this, so K is unknown, and B is 2H. And you are told also that there is this point P, okay, which is the intersection of this line y equals to 3x plus 2 and AC. Did they give you the point P coordinates? No, they didn't, but they tell you that 5AP, 5 times of this is equals to 2 times of AC. 2 times of AC. So 5 times of this is 2 times of this. Now, it's very hard for us human beings to visualize this. So what I normally recommend you do is you write it as a fraction. Whatever they give you here, okay, you just leave it here. You divide both sides by AC so that it becomes a fraction. Now, if you divide by AC, the 2 still remains here, right? But you need to divide both sides by 5, so 5 is here. What this means is that AP is 2 units. Okay, the length is not 2 units. It's, the ratio is AP over AC. The ratio that is 2 is to 5. Okay, so the actual length could be 4, 10. It could be 20, 50. We don't know. Okay, so this AP over AC equals 2 over 5. And what they're trying to tell you is AP divided by AC, right? You reduce to the simplest form, lowest terms is 2 over 5. The actual length, right, the unit could be 200 over 500. We don't know, and we don't really care also lah. Okay, so what we do now is we have to label on the diagram 2 units, and AC is 5. Okay, don't label AC as 5, okay? A good strategy in mathematics is label the parts. This is one part, this is another part, right? Don't label the big part, you label the small one, okay? Small one, we divide and conquer. So this is not 3. This is not 5, this is 3, yeah? Okay, so 2 over 5, correct? 2 over 5. So that's what you do here. Okay, this is important to help you to find this and this. Okay, now let's move on. Okay, what is this thing that I've drawn here? Okay, now this thing that I've drawn here, sorry, it looks a bit not so parallel. It should be parallel to this AC. I'm actually drawing AC. I'm extracting this line here only, this line. Forget about A, B, and BC, okay? These 2 lines, forget about it. I'm only looking at AC. This dotted line, these 2 dotted lines are not these 2, okay? Not these 2. I'm just dropping a line down from here. Okay, stop here, then I draw another horizontal line here. Why am I doing that? Because I know that this is 2, this is 3. Okay, now use common sense. There is actually like one triangle here and one big triangle here, okay? One triangle here, small one big one here. Now, if this is 2 units and this is 3 units, what does it mean? It must mean that this small one, which belongs to this small triangle, is 2 units, okay? And this 2, this whole thing must be 5, right? So this is 3 units, okay? Similarly, if I were to look at this part here, right? This part here belongs to this small triangle, so it should be 2 units. This part here belongs to this big triangle, big one, so it's not 3, it's 5. Yeah, it's 5, okay? So take a look, small over big. Small over big is 2 is to 5. Small over big is 2 is to 5. Small over big is 2 is to 5. Okay? This is something that you will learn in later chapter, alright? But never mind, we learn now, no problem. Very simple concept. Okay, now I follow this A, I label minus 5, 9. C, I label K minus 1, okay? I'm not interested in B. I'm not interested in B at all because I'm finding K first, alright? Now, how do I find K? Now, take a look at it. If this whole thing, okay, if this whole thing, if I'm able to find the length of this whole length, right? This whole length, if I'm able to find this length, and then I will be able to know how much each unit is equal to, because this whole thing is 5 units. Okay, I actually can tell from this y value and this y value that this whole length is actually 9 minus 1. Okay, think of it as this way. X here, y here, right? There's a point here whereby the y, we don't care about the x value. The y value is 9. Okay, then there's another point here, at the bottom. At the bottom here, the y value is minus 1. We don't care about the x value, okay? The x value not important in this case. Now, don't you agree that this vertical distance, this height here, is 9, then plus one more unit here? It's actually 9 minus 1. So actually it's 10 units. So 5 units is 10. This is the actual length of this. Wait, can you see? Okay, so you can find 3 units. Why do I want to find 3 units? Because I want to find out from here, this height, from this height, right? I want to go to this height where P is. I want to find out how many units, how far is P vertically upwards. I'm only interested in the y value, okay? I'm only interested in the y value. So don't you agree this is 3, this is 2 units, this is 3 units, okay? But the actual length is actually 6 units. This is the lowest terms, the simplest form. Okay, the 10 here is the actual length. Alright, so what I need to do is from minus 1, I move up 6 units. Minus 1 plus 5 will give me, minus 1 plus 6 units will give me 5. Okay, so that's why the y coordinate of P is 5. Meaning to say, P we know is actually something, the x value, and then 5. This is the difficult part. But once you know this, now this point lies on this line, right? This purple line. So it must obey this line. It must satisfy the line equation. So x, y, I put y as 5. I will be able to get, put y as 5, I will be able to get the x value. So that is my answer. That's all. Okay? Now using the same concept, using this ratio concept, you will be able to find K. But in this case, right, I want to find the x distance. I'm no longer interested in the y distance, okay? And which points am I interested in? Okay, I will be interested in A and P first, because I know that from A to P, I have to add 6 to minus 5 in order to reach 1. That means from minus 5, I plus 6, I will reach coordinate, x coordinate 1. Okay, which means that the 2 units here is 6. Alright, once I can find 1 unit, I'll be able to find these 3 units. Meaning to say that my K here is actually just 1, the x value, 1 plus 9, because this will be 9 units here, the actual units. Yeah, the actual unit here is 6. Actual units here is 9. So what I need to do is just take 1 plus 9. Okay. Now you may be asking how I get the 2 and the 3 here. Is the same thing. It's the same thing but drawn differently. Now notice again, I only draw the line AC, just like here I only draw the line AC, right? But now you see, instead of drawing the triangle this way and this way, right, I'm more interested in cutting here, because I want to know how long this, how many units this is, how many units this is. Now why is this 3? So why is this 3 and why is this 2? Okay, now we understand just now that this is 2, this is 3. 2, 3. So let me continue from here. Now look at this triangle. Isn't this triangle, okay, having sides of 3, 3, 3? Okay, and if this is 3, this must be 5. If this is 3, this must be 5. So this is 2. Okay, if this is 3, this must be 5. It has to be in ratio, in proportion. Okay, hope you understand this. Now that's the reason why this is 3, this is 2. Okay, if you don't understand, you try to digest from here. They are using the same concept. Okay, or if you don't understand at all, then just skip this question. But if you don't understand now, when we come to the topic, you also may not understand. So you might as well take some time now to try to understand. Okay, it will take you some time to understand. That's why I'm showing you first. Okay, let's move on. Let's move on. Now, how do I continue and do the other question? The other question wants you to find. We found K already. So K is 10. Okay. We have found H. No, we have not found H. H is what they want us to find. Okay. So there must be a reason why they tell us that this is 90 degrees, right? Now you learn in A Maths that if two lines are at right angles to each other, then this gradient AB, okay, is the reciprocal, the negative reciprocal of this, meaning you put a minus here, you change the sign of this, and then you flip the gradient of this. So this is the thing that we're going to use in this question. Okay, and this is what exactly what I did here. Where is this? Here. I find, I'll show you the diagram. I find AB, I find BC, and then I say since they are perpendicular, right? This gradient must be equals to the other gradient. You flip it, then you change the sign. Okay. Now don't be afraid to see all these fractions and all that. They will work out just fine later. So MAB is just this. Write down. This I have to flip it. So I get 2 minus k at the numerator, h plus 1 at the denominator, and I have to change the sign. Alright. Now the sign I can either multiply to the numerator or the denominator, and in this case I choose the numerator because the denominator is all positive, so I don't want to mess up the denominator. Okay, it's your choice. You see which one is more convenient. Alright, now after this I can cross multiply, and that's what I do. But before I do that, I know k equals 10, right? So you must be aware that you already know k. Then you cross multiply and all that, then you will get the answer. So that's all. That's all for this question. Pretty straightforward. The difficult one is actually the front part. Okay, now let's do it. That's all. Okay, now question 6 I think is a very simple question. So you just take a look at it. You see whether your answer match mine. I think that's all. Thank you.